All right, Juno, it's just you and me.
We'll make it work. Okay, I'm sure somebody else will show up sometime soon. We're on page 72. So we have, last time we were looking at, we had a reaction in a test tube, and it produced bubbles and the gas. I like this picture because it kind of shows, we have our zinc and our HCl. So our zinc is solid, our HCl is aqueous. And what would our products be of that reaction? Hydrogen. And sorry, what was the other one? Zinc chloride, yep, ZnCl2. So that's going to be aqueous. And that's going to be our gas. So there goes our little gas. You can see the gas molecules moving through there, and they bubble up. And if you recall, inside the collection tube, or in this case, it's a collection flask, we get not only the H2, but we also get water vapor above the water. So what we would need to do then is, this is where we use Dalton's law of partial pressures. So we have the pressure of, in our original example back here, we were doing a reaction that produced oxygen. And we also have the water. And we lifted it up and down until the level of the water was the same inside the gas collection tube as in the beaker. So the atmospheric pressure equals the pressure of the oxygen and the pressure of the O2. So now, if we know the temperature of the water, and let's say we're working at 25 degrees Celsius, you can look up on a table. You good? Okay, cool. You can just hand it in. You can look up on a table what the pressure is, and here we have 23.8 millimeters mercury. All right, and if we're told that the pressure of the atmosphere is 755 millimeters mercury, well, the pressure P atmosphere is equal to the pressure of the oxygen plus the pressure of the H2O. That's Dalton's law, okay? And we can solve it for PO2 because we know the water pressure and we know the atmospheric pressure. This is page 72, or maybe 73, page 73. Okay, and then you just do the subtraction, and we get 731 millimeters of mercury. Now, what they might ask you to do is they might ask you to solve the mole fraction. I don't think we've talked about mole fraction, have we? No, okay. It's a really straightforward concept. It's just the fraction of the moles that are O2, okay? And because pressure is proportional to moles, then if we take the pressure of O2 over the total pressure, then we'll have it'll be the same as the moles of O2 over the moles of O2 plus H2O. Does that make sense? Okay, cool. So we solve that and we get 0.968. So now we know that O2 is 96.8% of the total gas. Moles and volume and pressure, because pressure is proportional to moles, volume is proportional to moles, right? So they're all proportional to one another. And if you've got them as a ratio, it doesn't matter which one. Do you know what I mean? Like you can have PO2 over P total, NO2 over N total, VO2 over V total. Yeah, it all comes from that. So you've got PO2 over P total equals NO2 over N total is equal to volume of O2 over volume total. So at that point, what we can do is we can say, all right, we have our ratio is 0.968, which is 96.8 of the gas. All right, and if that is the case, if we want to find how much volume the gas takes up, so what is the volume of O2, we take our mole fraction, which is actually a decimal, so it's kind of funny that we call it a fraction. We take our mole fraction of the O2 and we multiply it by the total volume. So we're basically taking 96.8% of the total volume, which in this case, let's just assume that we collected 40 milliliters of gas over top of the water, okay? So if we collected 40 milliliters of gas, 96.8% of that is O2, and so we have collected 38.7 milliliters of O2 gas. All right, so I guess we should just make sure that we show this. This is the symbol for mole fraction. Hmm? I don't know. I like to put the things on it. Okay, that's mole fraction, and it is what is equal to, you can find it by doing the pressure of X over the pressure total, or the moles of X over the moles total, or volume of X over the volume total. And it's just a handy thing to be able to work with. And then we have some exercises. So I don't know, do you want to take some time to just do some of the exercises? Or would you rather do those at home and just learn something about real gases today? Up to you. There's only 2 of you. You get to pick. You'll do some exercises? What do you think? Yeah? Sure. So it'll be a short video today, unless you come up against some problems, in which case we can go over them. Yeah. What's that?
What is the mean oxygen?
Okay, so let's take a look at this. You can treat H gas separately. We have oxygen and nitrogen, and we have a 5-liter bulb containing O2, and we have an 8-liter bulb containing N2. And this one is at 295 torr, which is millimeters mercury. And the 8-liter is at 530 torr. Okay, so let's go through this one. Okay, so V1 of oxygen is 5 liters. Yeah? Once we have opened this, okay, that's the key. So we open the valve between them. Hi. The total volume will be 5 plus 8 is 13 liters. P1 for O2 is 295 torr, and then we have to solve for P2, and so we can use our P1 V1 equals P2 V2. And we would solve for P2. Add up what? To get the total pressure? No. No. Because that's after opening. Okay, so let's just get our pressure of the oxygen, because what's going to happen is oxygen is going to spread out so that it's evenly distributed between the 5 liters and the 8 liters. So you can imagine basically what's just happened for the oxygen is we've gone from a 5-liter container to a 13-liter container.
Oh, so we're looking at the whole thing for oxygen, not like
Yes. 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 Okay. So this is for O2. And we would have, let's see, P1 is 295 torr, and it doesn't matter what unit because they're all the same, so we can just use whatever unit we have. And we have 5 liters over P2, which is 530 torr. And if we do our calculation, we get 295 times 5 divided by 530 equals 2.783. What have I done? Oh my God, what is wrong with me? This should be V2. I'm so sorry. My brain is just stupid today. That should be a V2. Okay, and V2 is 13 liters. Oh my God. There we go. Ay, 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 ay. Okay. All right, so we have 295 times 5, divide by 13. That looks better. And we get 113.46. So that is the pressure of the O2 after we've opened the valve.
Oh, and then you do the same for nitrogen.
Yes. And then we do the same thing for nitrogen, so I'll let you guys do that. I'll do it up here and you can check your work with me, see if I do it wrong, which I probably will, because obviously that's how I roll. You good? Okay. Did we get 326.15? Okay. So now we can calculate the total pressure. We have 113.46 plus 326.15 torr. $439.61. We're not going to worry about sig figs here, okay? Because we have like an 8 liter. How many is it? Oh, okay, we have 8.00 liters. Okay, that's okay. We can do sig figs then. Would you assume that 530 torr had 2 sig figs or 3 sig figs based on this? 3, okay? So be reasonable about it when you see like that, okay? So everything here has at least 3 sig figs. So we're now going to have, and this is 113.46. Did you guys get the same numbers as I did? Excellent. And what would we get if we were to add these two numbers together? We would get 1 because it's 100%, right? Okay, excellent. Do you want to do this one together or separate? I don't know. Okay, let's try it. So we have nitrogen gases collect over water at 20 degrees Celsius. And pressure equals 1 atmosphere. The volume of the gas collected, which is going to be the total gas, that's going to be your N2 plus H2O, is equal to 250.0 liters. What is the mass of N2 collected? At 20 degrees, the vapor pressure of water is 17.5 torr. Okay. So first of all, that first pressure they give us, that is the atmospheric pressure. So that's going to be the water plus the N2. Yeah? So if we want the mass, that means we're going to want the moles. Yeah? So we want to find N, because in order to get mass, you always kind of have to go from somewhere like that, and you need moles. PV equals nRT, we'll be able to do it with that. So let's first of all figure out the pressure of the N2. What is our pressure of N2? Yeah. P total minus P H2O. Unfortunately, they are not in the same unit, but I do know that 1 atmosphere is 760 torr. So that makes life kind of nice. Yeah, so we don't even have to do like a conversion there. So we can say our total is 760 minus 17.5 torr. And we get 742.5 torr. Now, if we're going to solve for N, we would probably be using PV equals nRT, yeah? So we need the volume of nitrogen. What would we use to find the volume of nitrogen? Mole fraction. So we need the mole fraction of nitrogen times the total volume. All right, so the mole fraction of nitrogen is 742.5 torr. That's our pressure of N2 divided by 760 torr. And that's the pressure of total. $97.697. Oh, except for not like that, 0.97697. And our total volume, we were told we collected 250 liters. Okay, so times 250 equals 244.24 liters. We now have pressure of nitrogen we have volume of nitrogen, and we have the temperature, and we have R, and we could solve for N and then solve for grams. Is that good? Okay, we'll leave it there. Why don't you guys try number 3 for homework? Yeah? Through number 3 on page 75. Hi.
Do we have a test this week?
No, we'll have it next Wednesday.
Next Wednesday.
Yes.
Ooh.
Okay. We're going to do some practice quizzes this week, but I don't have time to mark anything for you guys because I'm doing report cards. So what I'll do is I'll give you practice quizzes and then we'll mark them together in class.
Okay.
Right? Thank you, guys.